Welcome to The Explainer. Today, we're going to break down the very substance of our world. You ever wonder what connects, say, the air you breathe to a piece of jewelry? Well, it turns out there's a surprisingly simple way to classify pretty much everything in the universe, and that's what we're unlocking today. Okay, let's start with a question. What could a gold ring, a glass of salt water, a sugar cube, and a salad possibly have in common? I mean, at first glance, absolutely nothing, right? You've got a shiny solid, a clear liquid, some sweet crystals, and a whole crunchy mix of stuff. But chemistry, as we're about to see, gives us a really brilliant way to organize all of it.
So to solve our little kitchen mystery, we need to zoom in. I mean, way in. We have to start with the most basic, the most fundamental building blocks that make up, well, everything.
So what exactly is an element? You can think of it as nature's purest ingredient. It's like a single fundamental Lego block. It's the one piece you just can't break down any further. That's an element for you. Now, the rules for being an element are pretty strict. And the number one most important rule, it has to be made of only one type of atom. That's it. This total purity is exactly what gives every single element its own unique and consistent properties. So, think back to that gold ring on our counter. It's a perfect real-world example. If you could somehow zoom in with a super-powered microscope, all you would see is gold atoms, billions and billions of them, and nothing else. And hey, it's not just shiny solids. The oxygen we're all breathing in right this second, that's another one of these fundamental elements. It's a gas made up of only oxygen atoms, and it's something we literally can't live without. Okay, so we've got these pure elements, but what happens when they start combining? This isn't just a random mashup, you know? They follow a very, very strict recipe to create something totally new. So here's the crucial point. A compound isn't just a casual mix. A chemical reaction has to happen, creating brand new bonds. The elements literally lock together in a precise, fixed ratio, and what you get is an entirely new substance. The magic of compounds is just incredible. I mean, you take two gases, hydrogen and oxygen, you combine them chemically in a perfect 2-to-1 ratio, and what do you get? Water, a liquid. It has completely different properties from the gases that made it. It's a total transformation. And this is exactly why the sugar cube and the water from our kitchen counter mystery fit right here. They're both classic compounds. Sugar has its own chemical formula, C12H22O11, and water, as we know, is always H2O. That fixed composition, that's what makes them what they are.
But what happens when substances are just, tossed in a bowl together? What if there's no chemical reaction, no new bonds, no strict recipe? Well, that's where our third big category comes in.
This is so key. In a mixture, the original ingredients are all still there. They're just physically sharing the same space. The salt in salt water is still salt. The water is still water. They haven't become a new thing.
Honestly, this distinction right here is probably the most important takeaway from this whole explainer. Think of it like this. It's the difference between a salad and a cookie. You can physically pick the tomatoes out of a salad, right? But you can't pick the flour and sugar out of a cookie once it's baked. One is a mixture, the other involved a chemical change.
Now, mixtures themselves come in two main flavors. The first is what we call a homogeneous mixture, which just means the same throughout. Our salt water from the counter is a perfect example. Once that salt dissolves, you can't see the individual little bits. The whole thing looks completely uniform. And the second flavor? That's heterogeneous, meaning different throughout. Now think back to that salad, or maybe the oil and vinegar dressing you'd put on it. You can easily see all the different parts, the lettuce, the cucumber, those little blobs of oil. The composition is definitely not uniform. Okay, so let's zoom back out to our kitchen counter. Now that we have our categories, elements, compounds, and the two types of mixtures, we can finally solve the puzzle. This table is a fantastic little summary. It just lays out the core identity of each classification we've been talking about, all side by side. You can really see how the composition and how you can separate it. Those are the key things that tell you what you're dealing with. And there it is, the solution. The gold ring is a pure element. The sugar and water are both compounds. The salt water is a homogeneous mixture. And that salad, a classic heterogeneous mixture. We did it. We successfully classified everything and turned a simple kitchen scene into a whole chemistry lesson. So, we'll leave you with this final thought. Water, H2O, is a compound. The air we breathe is a mixture of gases. Both are absolutely essential for our survival. So why is that distinction?
compound versus mixture, so important? Well, because understanding that difference isn't just for a science test. It's fundamental to everything from medicine and manufacturing to how we protect our own planet.